I make this video for my class EL6303, and here is the second question in my homework 3. So first we're gonna find and draw the distribution function of x. And here is the solution. Because x is uniform in the range from -1 to 2, so obviously the density function should be 1/3, and the range of the x is from -1 to 2. So later the distribution function could be easily get. Here's the distribution function, and here's the picture of here's the figure of the distribution function, and it should start from -1, and I made a mistake here, so just ignore this line. It should start from -1 and later to 2, so it will rise from this point to 1. Later it would be just later the distribution function would equals 1. So here we're gonna move to the second question. We need to find and draw the density function y. The distribution function of y equals the probability that y is smaller or equal to y. So here, because y equals x squared, so the y could change to x squared. Later it could be written into this way. So this probability could rewrite to distribution function way. In the distribution function way, we could know that the distribution function of x is minus the distribution function of x. It should be like this. Obviously, when y in the range from 0 to 1, the density function of y should be this one. We just need to use the first use the result in the first question and in the first result, so we could get this. And later, if the range of y is from 1 to 4, so the density function of y should be this. Obviously, we use the result from question 1 as well. So this is the density function of y. Here is a figure of density function y. From 0 to 1, the density function would be this part, and from 1 to 4, the density function would be this part. And later we're gonna talk about the third question. The third question is that we need to find and draw the density, the distribution function y. The distribution function y could be written into this way. So when y is smaller or equals to 0, obviously the distribution function of y equals 2, since we could either get from this figure, because when y is smaller or equals 0, then the density function equals to 0. So later, if y is in the range from 0 to 1, so the distribution function could be written into this way, and obviously this could write to 0. We just need to count it from 0 to y. So this part, later the result of it would be this. And if y is in the range from 1 to 4, so the density function could be right into this. Obviously, all these are count on the density function of y. So because of this, so the distribution function could be right into this. Later, we could get the distribution function of y, and here is the distribution function of y. We need to draw that. Obviously, it could be divided into 4 parts. If y is smaller than 0, it would be 0. If y is in the range from 0 to 1, we should use this function, this part. If y is in the range from 1 to 4, so we should use this function, this part. And later, if y is bigger than 4, so it means the distribution function of y equals 1. So just is this part. So here's the figure of the distribution function of y. In the last question, we need to find the expectation of y. If obviously the expectation of y equals to the expectation of x squared. So we have already know that the density function of x equals to 1 by 3. So in this part, it's really easy to get the result. It should start from the -1 to 2, since the density function of x, the range of density function of x is start from the -1 to 2. So this is the result. And here is the solution for the second question in my homework 3.